Have you ever looked around and noticed that there seems to be some kind of hidden rule to the patterns we see everywhere? A secret mathematical code that explains why some things fit together so perfectly and other things just don't? Well, today we're going to crack that code. You see this rule playing out all over the natural world. I mean, just think about a honeycomb. Every single one of those hexagonal cells snuggles up against its neighbors perfectly. There are no gaps, no wasted space. It's just this incredible piece of natural engineering. And it's not just out in a field somewhere, it's right in our own homes. Just look down at a tiled floor or glance over at a brick wall. It's the exact same principle in action. Shapes covering a surface, totally seamless, with zero gaps and zero overlaps. So what if I told you that the bee's honeycomb and your bathroom tiles are following the exact same rule? It's kind of like this universal code for patterns that's been hiding in plain sight this whole time. And once you see it, you can't unsee it. You start finding it everywhere. This really brings us to the big mystery, right? Why can you tile a floor with perfect squares, but it's impossible to do it with regular pentagons? Why do some shapes create these flawless, beautiful patterns, while others just leave these frustrating gaps or messy overlaps? There's a very, very specific reason, and we're about to unlock it. So the official word for these perfect-fitting patterns is a tessellation. Yeah, it's a bit of a fancy term, but the idea behind it is actually incredibly simple and really powerful. Let's break down what that really means. Okay, so a tessellation is basically any pattern that covers a flat surface. You know, like a floor, a wall, a piece of paper, with shapes that fit together like a perfect puzzle. And there are two golden rules here, and they are non-negotiable. Absolutely no overlaps and absolutely no gaps. So what is the secret? What's the hidden code that makes it all work? Well, it all comes down to this one simple, elegant number, 360 degrees. That's it. This is the key to everything. And this number gives us an amazing little tool. We can call it the 360-degree test. You can use this test on pretty much any shape to figure out with total mathematical certainty if it's going to create a perfect pattern or not. Here's the rule, plain and simple. For a pattern to work, the corners of your shapes have to all meet up at a single point. And right at that meeting point, the angles from each of those corners have to add up to exactly 360 degrees. Why? Well, because 360 degrees makes a perfect full circle. Any less, and you get a gap. Any more, and you get an overlap. It's that simple. All right, enough theory. Let's take our new secret weapon, that 360-degree rule, and actually put it to the test with some common shapes. Let's find out who the winners and losers are. And right out of the gate, we've got some clear winners. An equilateral triangle, its corners are 60 degrees. 6 of them meet up, and boom, 360 on the dot. A square has 90-degree corners. You need 4 of them to make 360. And a hexagon's corners are 120 degrees, so just 3 of them fit together perfectly. But what's the deal with the pentagon and the octagon? Let's dig in. So let's zoom in on our problem child, the pentagon. The issue starts with its angles. See, each corner of a regular pentagon is exactly 108 degrees, and that number, 108, is the source of all our trouble. Okay, so let's try to fit them together. If we bring the corners of 3 pentagons to a single point, we get 3 times 108, which is 324 degrees. Well, that's not our magic number of 360. And what does that mean? It means you're left with this annoying, undeniable gap. It fails the test. All right, so you might think, well, let's just try to force it. Let's squeeze in a 4th one. If we do that, we have 4 times 108, which is 432 degrees. Whoa, that's way over 360, so now the shapes are literally crashing into each other. They overlap. The bottom line is, there is no whole number of pentagons that will ever hit that 360-degree mark. It is mathematically impossible. And guess what? The poor regular octagon has the exact same problem. Its corners are 135 degrees. 2 of them only get you to 270, leaving a huge gap. But 3 of them jumps you all the way to 405, causing a big overlap. Again, the 360-degree rule shows us why it just doesn't work. So when you lay it all out like this, the results are crystal clear. If we're talking about regular polygons, with equal sides and angles, only 3 of them can tile a surface all by themselves: the triangle, the square, and the hexagon. The math just doesn't lie.
But, and this is where it gets really, really cool, this rule isn't just for these perfect, simple shapes. The 360-degree test is actually way more flexible and honestly more creative than you might think.
Because that exact same rule applies to all sorts of irregular shapes. Fun fact, any four-sided shape, no matter how weird and wacky it looks, can tessellate. The rule also explains how we can combine different shapes, like you see in those intricate tile floors with hexagons and triangles. It's the hidden secret behind everything from quilt patterns to the design of video game worlds.
And that really shows you the true power of this rule. It's not a limitation, it's actually a framework for creativity. The artist M.C. Escher was an absolute master of this. He used these fundamental rules of tessellation to create his world-famous art of interlocking birds and fish and lizards that all fit together with pure mathematical perfection. He literally turned a geometric rule into breathtaking art. So, the next time you're walking down the street, I want you to look closer. Look at the bricks in a wall, the tiles on the floor of a cafe, even the pattern on a piece of fabric. You now have the key. You understand the hidden geometry that's all around us. The only question left is, what new patterns are you going to find?